All right, today is the 17th all day long. So, we are still continuing on with our work with factoring. So, we were somewhere right around here-ish. Where'd your notes go, dude?
I have no idea, actually.
Yeah, you checked everywhere in your Bible. I'm tired of taking my extras. I've gone through more extras this year than I ever have. You guys need to stop losing your crap. What if you owed me $1 every time you lost your notes? Because, you're wasting school money. Almost every single one of you has probably lost something at some point this year. And if you haven't, kudos to you. But when you do that, you're wasting school resources because you can't stay organized. Think about that. What if you owed us $1 every time you lost something? I don't think people would lose things either. I agree with that thought. I don't know. I feel like we need to apply something like that. So we were here finishing up factoring that out. So who can remind me what the common factor was? Because right at the end of class, we realized it wasn't what we had thought it was. We thought for a moment that we might be able to use 4. Because 12 can divide by 4, 16 can divide by 4. But 10 could not divide by 4. So instead, we got to this, right, guys? We started this. Am I crazy? Here? Oh, that's why you're looking at me like I'm crazy. So, did we get through this that you understand what the process is doing? Let's review this. When we look at factoring, we want to say what is common to both terms. Here, I don't care as much about factoring out a number because they're both decimal values. I mean, I could really divide by anything that I want. I'll just get kind of messy values. But if I divide by A, so go ahead and in your notes, show here that we're going to divide by A and divide by A. That then becomes the coefficient to your binomial. So that's where that A comes from. You then put the original coefficients together to combine those and find out that we in total have a 2.2a. Now you don't have to do this step. It is not required. It is not necessary. But if you are struggling to understand what's going on, that's why we can combine like terms. Because we technically factor out the variable, add the numbers together, or subtract, whatever it's telling us to do, and then put the variable back on. So this is why we are allowed to combine like terms. Like terms must have, did we talk about the two things they must have? Abby? Same variable or lack of variable, but not having a variable is the same as, so like terms, same variable, and this won't matter right now, but later it will. Power, or exponent. So like x versus x squared, those are not like terms. Even though they both have x, these are not like terms. I have a handheld sharpener up here. We've talked about this multiple times. That's not working. Center drawer up here. So when we come down here, our goal with this section is to factor these out, center drawer, as completely as possible. So a couple of them give you a start. So let's start with these two to begin with. I'm going to zoom in a little bit more. So they already show us that 4 is our greatest common factor. So we know that we really divided by 4 and divided by 4. That's what got our 4 there. So please show those divisions. All the way at the bottom of that front page. So, when we divide 8a by 4, Grace, what do we get? 8 divided by 4, 2a. So we get 2a in here. And actually, I'm going to color code this so it makes sense to you guys. This gives us the 2a. And then this will give us 1, right? A number divided by itself. doesn't disappear. It cancels out to 1. Any questions on that first one? They gave us our common factor, so we knew we had to divide by 4. Joe, you got that written down? So now on my second one here, CJ.
Does it have to be your highest common factor?
Greatest common factor. So yeah, we could have divided by 2 here, but that's not the greatest common factor. So you got to have the biggest number that you can divide both of them by. So, Andrew, here they give us the values inside the binomial. They don't give us our common factor. So what we have to think through is, what could I divide both of these by? What is common to each of them? The m. So we divide by m and m. We get m as our common factor out front. And we see this 3.5m divided by m gives us just 3.5. Exactly. And this mn divided by m just becomes the n. Any questions on either of those first 2? Try the next 3 on your own. I mean, you can check with your partners close by, anything like that. Stick up a hand if you are struggling to figure out what we're doing. So think, what could 14 and 21 both divide by? Can 21 divide by 14? The whole word? No, so think smaller. What x can 21 divide by x? There is no x. Think of just the square. Is there an x in 21? So when we're thinking through this, Jaheim, when you look at 14x and 21, do they both have variables in them? Do they both have letters, variables in them? Just the 14, right? So you know that if both of them don't have variables, you can't divide by a variable. So throw that idea out the window. Think about, what number could we divide by? 7. So I divide by 7 here and divide by 7 there. 7 becomes my greatest common factor, which goes in front. Then my 14x divided by 7 gives me what, Jaheim? Do the numbers. 2, yeah. 2, then bring the x along for the ride, so it's 2x. Then 21 divided by 7, Jaheim, is 3, and now we're done. So we get 7 times the quantity of 2x plus 3. Questions on that? On my y minus xy, Anthony. Hey, you're back there today. What is common to both of them? The y value. I was going to be snarky and say because I asked, but then people get confused. Don't you guys think Mrs. Golding's cell phone sounds like an angry monkey? Like playing a xylophone? That's what Mrs. Cullen is. She's always like, I'm going to throw that angry monkey out the window. Because she always has, it's understandable that she has a ringer on. She's got a family and everything, but we always joke about the angry monkey. All right, so when I divide by the y comes out front. Y divided by y, Anthony, what's that give you? Ooh, a number divided by itself is 1. Remember, even when it's a variable, it represents a number. This is a number divided by itself. Then, xy divided by y, just the x. Any questions on those? The last one I kind of gave away because I thought we had made it that far. So when I look at 12a, 16b, and 10c, They all have variables in them. Great. But they're all different. Crap. So, you can't divide by a variable because they're all different. Izzy, what could we divide by? Sure, yeah. Speak up a little bit if you can.
Okay, and then you divide 12a by 2, which is 6a. Plus, like right here, plus over, and then it's 6b divided by 2, which is 8b. And then, and I say what it is. Well,
Yep. Black, probably. Any questions? Because we're saying if we apply the distributive property, we will get back to where we started. Abby?
Also, wouldn't you not be able to like subtract that evenly either?
What do you mean subtract that? You like in this parentheses, you
Oh, wait,
can't
you
do
can't.
this. You're like, we're
There's no-
done. Yeah, we're done right here. So, try this one. On the back, 12x minus 42y minus 3. You got to find that greatest common factor, factor it out, and write it in the correct form. Yep. Any questions? You should not. I'm not saying you can't, but you shouldn't. Question or answer? Yep. So look, do they all have variable values? So they're different, and this one doesn't have variable values, so we can't divide by variable. So now think two numbers. What number can we divide every single piece of this by? I have a stack of cards telling me who to call. Shane, what did you find as a common factor we could divide all three of these by? The 3. Now, the option here is whether I use 3 or negative 3. I don't want to make things hard on you yet. So just know you could use 3 or negative 3 as your common factor. So 3, 3, 3. Technically, because often there's somebody who's at least wondering which one would be better. Here, because 2 of my values are negative, technically using the negative 3 would be better, but we're not going to do that. We're not going to do that today. So a minus is a negative. A negative is a minus. Because if I rewrite this, it's 12x plus negative 42y plus negative 3. The only reason we use minus is to clean this up. There's no such thing as subtraction. It was invented to represent adding a loss or adding a negative amount. I know this is weird. We should teach this from the get-go. Subtraction is an invented idea. I can keep giving you stuff, and I can take things away from you. Yeah, it is. It's all invented to make sense of the world. And that's how we put a man on the moon. We made sense. We did put a man on his moon. We made sense of our world to the point that we could extend that knowledge to literally putting some people in a rocket and shooting them off our planet onto something else. So, even though math is all invented, and actually, in my high school math 2 class, I have my kids write an essay on was math invented or discovered. Like, everything that is explained by math would happen if we weren't here. waves would still happen, gravity would still work, like it would all still happen whether or not we were here to see it. So that's going a little deeper than we need to. There is math 1. I teach a math 2 class because they already took math 1. So when 3 is my common factor, Shane, I'm coming back to you. 12x divided by 3 gave me 4x. 42y divided by 3, since I took the minus as a minus, it's not negative. I took it as a minus, so I can just do 42y divided by 3 is 14y. Nope, that would be 45. And then the 3 divided by the 3 gives me a 1. Any questions? Yeah. No, because 3 can't divide by 6. You want to end up with whole numbers. You want to end up with integers. So avoid those partials. Again, like terms, same variable and same power. So here's your example. Even though both of these have an x value, they have different powers. They are not like terms. If they both have an x in them, but one has xy and the other has x, they don't have the same variable parts. This has xy, this has x. Different, they're not. And then if one has a variable and the other doesn't, one's a variable, one's a constant, they're different. Not like terms. You cannot add or subtract non-like terms. You can multiply and divide anything you feel like, but adding and subtracting is specific. So in this next example, which of those can be combined? Which of these can be combined? Michaela, let's call these option A and option B. In option A, what do you notice about both values? Yeah, they both have X in them. Do either of them have any other letters involved? Like X is the only letter that we see, right? So these have the same variable parts. Can we add them? Yeah, because they're like terms, same variable parts. They are like terms. This, though, I would prefer if for a moment you would rewrite this is really negative 1x, because we don't show the 1, plus 3.5x. In the end, gives me, Jack, what do you get? Yeah, it would help if we were sitting up, paying attention. Casey, what do you get? If we were at negative 1, we go up by 3.5. Yeah. Yeah. 2.5x. Guys, use my number line to visualize if you need to. If I'm at negative 1 and I go up by 3, then another half, land at 2.5. Yeah, you can do it. Open your eyes. Observe the world. So here, these are non-like. Please label what kind of term is 7. Flynn, what kind of term is 7? Is it a constant or a variable? Do we know what it is or could it change? So like, if you have 7 bananas and you go like get a drink and you come back, could there be 24 bananas now? No, because if you knew how many there were, you know how many there are. So that we call a constant. The 2x or the minus 2x or negative 2x, however you want to look at it, I don't know what x is. So it is a variable. then I plug it in and it turns into a constant. Like once you know, like if x is 3, now I know that this 2x is really 6. And then it's a constant. But while it's a variable, it's a variable. Like while I don't know what x is.
There's something that we like called last, and I thought it was
An unknown. Now you're going to see these on your homework. And I helped a couple people yesterday. And by helping them, I said, go look at your notes. So when you come to ask me for help, you need to have already been using your notes and be writing things down. Not every question needs work written down, but a lot do. When we increase prices, so we have a produce manager that says he's going to increase all the prices of the fruits by 3%. It's inflation. That happens every single year. Prices increase. You just don't realize it because it happens slowly. So if we increase by 3%, that really tells me that we're going to go up or add 3%, which really means we're going to add 0.03, but 0.03 of what? Well, it's 3%. Is he? Yeah, it's 3% of what it was, or of the previous price. So if P represents the previous price, so P is the original price. You might want to underline or highlight this. P is the original price. This is really 100% because it's 1P. This is adding 3% more. So what we're going to end up with, if I had 100% and I add 3% to it, Xavier, 103%, which we would write 1.03 P. Because this P is really a 1P plus 0.03 P. Always remember there's a 1 in front of any variable that doesn't have a coefficient. This variable has a coefficient already, but this one doesn't, so we know there's a 1 there. Abby?
Do you still want to multiply that by 100?
It depends if we want to talk in rate form or percent form. If we want to talk in percent form, then we can multiply this and say this is now 103% of the previous price.
But we're not like making it like equal percent. We're trying to make it into what the previous.
We're trying to simplify this expression.
Okay, that makes sense.
So the two ways the produce manager can find the new price of fruit: the tiresome, lame, not very good at math way. You have the old price. Find out 3% of the old price, calculating separately, then add them together. That takes a long time. The quicker way, just do 1.03 times the old price, you're done. You find your new price. One step, that's it. Because that took into account your original and the new increase. Any questions? Same thing happens when we discount. So bakeries have to discount things all the time because they go bad pretty quickly. Which is good. That's how you know something is good for you, that it can actually go bad. Food that doesn't go bad, not very good for you.
Probably artificial.
Yeah, preservatives. So, B represents the original bread price. So you might want to highlight B is my original bread price. That would represent 100%. We are going to make all prices 15% off. So Justin, if I save 15% off, how much does that mean I'm going to pay? Yeah, if we save 15%, we pay 85. So when we do this subtraction, we really get 0.85 times B. Because this tells me I'm going to pay 85%. I don't know what you mean.
Like, if you have a percent, like 100%, it can't be like 100.
Well, it's 100% of what? You have to communicate what you're talking about. That's why we a lot of times use a variable. Communicate what it is that we're actually talking about.
So like you can't actually
Excuse me.
have like a variable.
Thank you. Appreciate that. Clear. So, our equivalent expression tells us that the new price compared to the old price, which is better? The new price, right? It's less. So this tells me my new price, we already said, is 85% of the old price. It's cheaper. It's on sale. It's been discounted. Using that same method, if you save 30% off of something, your friend says, oh, dude, easy way to find your price. Just take the old price and multiply it by 0.07. Or sorry, by 0.7. Got dyslexic there. Is your friend right? They say you can calculate the sale by doing 0.7 times the original price. Lily, what do you think?
I think that
What would 0.7 represent? So if we save 30% off, what percent am I left to pay? If we save or discount 30% off the price, we take 30%, get rid of it. What percent is left? 100% minus 30. Yeah, I knew if I waited, you'd get there. So 30% off tells me we'll pay 70%. So can I just multiply by 0.7? Does that represent 70%? Yeah, this works because this is just 70% of the whole. Guys, this is parts equals percent times whole. It's just the percent formula. It's just an application. Other questions from this set of notes? We are. We're going to start.
Oh, please.
Pass these back to the desks where people are, even if they're in the restroom. There's a couple people gone right now. Got you, Jeff.
I already have.
Why do you already have some?
Remember yesterday there was a picture?
Oh. Oh, yeah. You guys might also already have 7. 5 of you.
I like the Wait.
Please pass them back to Shane, Jack. Pass them back. So, when we talk about adding expressions, what's really important is that we pay attention to like terms, which we just talked about in this last lesson. But it gets tricky because we incorporate lots of variable terms and a variety of constant values. We have a positive or negative or decimal or fraction, or we see all kinds of different constants. So let's re-identify what each of these terms is. Who thinks they can define what a constant term is? Like the simplest definition that we can give it. Abby?
A constant term is a term where it doesn't have any variable or power to it.
Okay, no variable, well, it could have a power, because numbers can have powers on them.
Oh yeah, just no.
So no variables. What about,
And it stands by itself.
yeah, why do we call it a constant?
Because
Keep
it
it.
doesn't change.
Yeah, and, like, what's the difference between a constant and a variable?
then the variable could mean something, so it can change.
Well, yeah, we just don't know what it is, right? So a constant, what I want you guys to have down here, is a known value no variables, or actually we could say no letters, can't change. It's constant. It will stay the same. It's a known value. We have to be told what it is. Has no letters involved, and it cannot change. Is a lonely life for a constant. A variable term. I can't hear. Well, no, constants can be combined with each other. They just need other constants. Now, if you can't change, it might not be a good relationship, though, if you're unwilling to change. A variable term, contrary to a constant. No? Well, it's unknown. So not that it can change, but it's unknown.
Wait.
Unknown value. Has a letter. Or multiple letters. So we put the S in parentheses. Has a letter or letters. Did somebody put 7-3 on your desk? Sweet. Awesome. Abby? For coefficient?
Yeah. I remember.
Unknown has letters. I'm trying to think if there's anything else we need to say about a variable. Either of these could have powers, so let's just not say anything about powers. Let's move on to coefficient. What is the coefficient value? Hold on. Anybody else? We don't want to let Abby just run the whole show. All right. Help us with our vocab.
So a coefficient can have a power and a variable. Like it can.
Not quite.
No.
I mean, it can, saying that a coefficient could have a power is kind of, it'd be weird if our coefficient had a power. We would just go ahead and do what the power told us and find out what the number actually is. What's the point of a coefficient? It's down, like you see down here, with these three terms, you have a couple coefficients. CJ? Kind of. It's doing something with the variable. Andrew?
Isn't it a constant times a variable?
It is a constant multiplier to a variable. A constant multiplier to a variable. So this -5, it's going to do -5 times whatever the x is. We don't show it, but there's a 1 out here. That's 1 times the y. You've got 1 y there. So think of this as like constants are like money. When you have money, it's countable. You know what it is. But when you go to the grocery store and you buy like fruits or vegetables or things like that, you don't necessarily know what they cost. So you might go to the store with $10 and you might then subtract that you're going to buy 3 bananas, and then you'll end up with some amount of money after you get done with that. Or not, or maybe you can't buy it. But I hope with $10 I can buy 3 bananas. So think about like constants like money. Like you know what it is, you have it, it's solid, it's not going to change. Prices, on the other hand, like price of gas, price of bananas, price of apple, any of that stuff can change. I wanted to. We didn't quite have time when we were in the airport. I was about to go to one of the currency exchange places and just get as many different types of money as possible. But like next time you're in an international airport, like I don't know how often you guys travel, but go, if you have a chance, check out what the exchange rate is, because it's always changing. Yeah? Nice. If you would like to like take a couple bucks and get it exchanged to a different currency, that's sometimes fun. See how much you get. It doesn't matter if you're in an international airport, they'll have a currency exchange station. Yeah.
Yeah, I think I am too. Because in February, our parents go on like this trip because my dad has like this work thing in February. So they were thinking that me, my sister, and my brother can fly to Florida and go with my grandparents.
So, here's a thing that many of you are struggling with. So I would like you to put a star or some kind of notification. Addition is like, or really we can say subtraction is addition. Kind of. Subtraction is addition, kind of. So when I have a subtraction problem, I can easily rewrite that as addition problem by just taking the minus, and instead of just saying minus, saying plus the negative. So we still have one of the symbols. It just moved from being a minus to being a negative. So subtraction is really just addition, but it's addition of a negative. So subtraction is addition of a negative.
Not kind of the negative.
Let's see if we can get through a couple of these. Let's do the first one together so you guys get a hang for what we're doing. And maybe you guys will be able to do the next three on your own. So Hayden, when we look at the 12a minus 3, how many different terms are there? So what kind of term would 12a be? Would it be a constant or a variable? Variable, right? What kind of term would 3 be? I can't hear you, dude. A constant, right? So we have a variable term, a constant term. How many terms do we have? 2. We have 2 terms. So put a 2 in that table. Right, Maylee? What is, or what are, my coefficient in that value, CJ? What coefficient exists there? 12, because it's the multiplier on the value, or on the variable. Then, this is where people screw up. Abby, your card's actually up. What's the constant?
Isn't the constant 3?
No.
It's not 3.
Atticus?
Wait.
Nope, that's the variable. Kylie? Jack? I thought you were there. Julia? Constant?
No, now.
Wait, no, but he's calling cards.
If you think you know it,
9.
good. He did 12 minus 3.
-3.
It's negative 3.
I was close.
The sign. Hey, hold up.
Closer than you.
I'll wait, because we release once I get to say this. The sign in front of a term has to go with the term. There's a positive sign in front of here. You just don't see it. The negative or the subtraction sign has to go with it. We'll pick it up right here tomorrow. Tomorrow's your chapter 3 test. We will not pick these up tomorrow. Tomorrow's your chapter 3 test. Please be ready.
Sleeping.